This is Geometry Unit 3, Lesson 5 on the distance formula. When we want to find the distance between 2 points, we are actually looking for the length of the line segment that is determined by the 2 points. Remember, the line segment has the 2 endpoints. The distance would be how far it is between them. Now, measuring distance depends on the kind of segment that you have. Let's take a look at this triangle. We have point A is at 1, 4. Point B is at 1, -2. And point C is at 5, -2. Now, let's take a look at the different segments that make up the line. Our first one, or make up our triangle, is BC. What kind of segment's BC? Well, it is a horizontal segment. Notice the coordinates here, the distance from B to C, the y coordinate is the same. So that's how I know it's horizontal. So, to find the distance from B to C, because it's horizontal, I can just count the boxes. 1, 2, 3, 4. So the length of BC is 4. Now, like I said, the horizontal line has the y coordinate the same. So to find the distance, you can also take the absolute value of the difference of the x coordinates. So the change in the x's. You go from 1 to 5. So delta x, or the change in x, is the absolute value of 1 minus 5, which is equal to the absolute value of 4, which is 4. So if it is horizontal, you can count or just find the difference between the x's. And notice its absolute value because distance always has to be positive. Now we found that the distance from B to C we said was 4 because that is a horizontal segment. Now let's look at AB. AB is a vertical segment. It is the distance from A to B. Now again, notice one of your coordinates is the same. The coordinate for A is 1, 4, B is 1, -2. The x coordinates are the same. So we can actually just count the difference between the y's, which is the horizontal distance. So count the boxes. 1, 2, 3, 4, 5, 6. So this side from A to B is 6. So AB is 6. Now, we can also, since the x coordinates are the same, take the absolute value of the difference of the y coordinates because that's the only thing that's going to change. So the distance will equal the absolute value of the change in y. So the change in y for line AB goes from 4 to -2. So it's 4 minus -2, which is the absolute value of 6, which is equal to 6. So the length of AB is just found by finding the difference between the y coordinates because the x coordinate didn't change. So if you have a vertical line like AB or a horizontal line like BC, you can just count the blocks or just find the difference between the coordinates that aren't the same. So those are easy. It comes down to when you don't have a horizontal or vertical segment that it comes a little more complicated. Now, AC on our diagram is actually a diagonal segment. This line right here is diagonal. We can't count the boxes from here to here. It doesn't work because some of these are partial boxes, some are not, and the distance is not the same. However, what do we notice? Distance can't be found by counting, but AC is actually the hypotenuse of a right triangle formed by these two lines, or two segments. So if you look at the triangle right here, this is a vertical line and a horizontal line. Remember, those are always perpendicular to each other. That makes this a right angle, and that makes this side, AC, the hypotenuse. So, since we know the length of the vertical segment and the horizontal segment, why can't we use the Pythagorean theorem to find the length of AC? And that is what we can do. So, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. You may also see it as a squared plus b squared equals c squared, where c is the hypotenuse. Remember, when you're using the Pythagorean theorem, the hypotenuse has to go over here. The leg, it doesn't really matter which one is which, but the hypotenuse has to be there. The hypotenuse is across from the right angle. So, if we are looking for the length of AC, AC is my hypotenuse, that's what I'm looking for. So I'm going to put AC squared in there. My other two legs are AB and BC. So I'm going to put in 6 and 4 squared. So 6 squared plus 4 squared. So solving for AC squared, we get 6 squared is 36, 4 squared is 16, is equal to AC squared. Add these together, 36 and 16 is 52. is equal to AC squared. All right, so if this is squared, how do we unsquare it? Well, we take the square root of both sides. So AC is equal to the square root of 52. Now that is the exact value. We can actually simplify it or round it off if we're asked to calculate with it. So unless you're asked, leave it as the square root of 52. But if you want to figure out the actual value, or excuse me, the approximate value, you can take the square root in your calculator of 52, which is approximately 7.21. So if you do the square root of 52 in your calculator, you get approximately 7.21. Unless you are asked for it, leave it as the square root of 52. Now, why did we do that? Well, what we just did is the derivation of the distance formula, where the distance formula comes from. The distance formula is used to find the length of any segment. No matter what kind of segment it is, you can use the distance formula for it. It is actually derived from the Pythagorean Theorem. Now remember, in the previous examples, we used the vertical and the horizontal to find the distance here. We made a triangle out of this. This distance from here to here, the horizontal distance, is the change in x. So going from this point to this point, the x changed this much. And going from this point to this point, the y changed from here to here. That change in y is your vertical distance. Notice it makes a triangle. Now remember, we said the Pythagorean theorem says leg squared, which would be here, delta x squared, plus delta y squared would equal d squared. All right, leg squared plus leg squared equals hypotenuse squared. Well, if we solve this for d, if we take the square root of both sides, we actually get this formula. Remember, delta x and delta y actually mean x2 minus x1 and y2 minus y1. So that's what they mean. So when you solve for d, you actually get this formula. This is the distance formula. You need to know this formula. So we want to be able to apply this formula to using it to find the length of segments. Now, an important part of using the distance formula is know when to use the formula and when to use the Pythagorean theorem. So let's take a look at this problem right here. Find the length of AB in the graph shown. Now, I could use the distance formula on this pretty easily, but if I have the graph, wouldn't it be easier just to make a rectangle or a triangle out of this? Draw the vertical, draw the horizontal, here's your right angle, and count your boxes. 1, 2, 3, 4, 5 is this side. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is this side. So we can use AB as our hypotenuse and apply the Pythagorean theorem to this because it's easier just to count this. So if we want to find the length of AB, it would be 5 squared plus 12 squared, that's the vertical and the horizontal, is equal to AB squared. 5 squared is 25, 12 squared is 144, is equal to AB squared, and that equals 169, which is AB squared, and then take the square root of both sides, and I do know the square root of 169 is 13, so AB is equal to 13. So if you have a graph, make a triangle out of the segment so that the segment that you're looking for is the hypotenuse. It's much easier to work with from there. Now, if we wanted to find the distance between two given points, 35, 112, and negative 17, 48. Now, that would be a pretty big graph to have to graph this. So, this one would be ideal for using the distance formula. Just to remind us, the distance formula is d equals the square root of delta x quantity squared plus delta y quantity squared. Difference between the x's squared plus the difference between the y squared. So I'm going to make this one x1, y1, x2, y2. So I know which one is which and if I've used them or not. So using my formula, d equals the difference between the x's. Well, that would be negative 17 minus 35. And then that's squared plus the difference between the y's. 48 minus 112 quantity squared. So, using my calculator and my values, negative 17 minus 35 is negative 52. squared, excuse the bell, plus 48 minus 112 squared is negative 64 squared. Okay, now be very, very careful. Remember when you square a negative on your calculator, be very, very careful. Negative 52 squared has to be in parentheses or else it won't square the negative. So negative 52 squared plus parenthesis negative 112 or 64 squared, excuse me, is equal to 6,800. So D is equal to the square root of 6,800. If you do not use your parentheses, it will give you a negative under the square root, which you can't do. The answer is actually 6,800. So the exact value is D is equal to the square root of 6,800. Now, if you want to approximate that, you would just take the square root of both sides. Or you have to take the square root of both sides, 6,800. And you want to approximate the value. It's approximately 82.46 or 82.5, depending on where you round it off. So this is approximately 82.5. Unless you are asked for an approximation, leave it as D equals the square root of 6,800. So you can see all I did was find the difference between the x's squared plus the difference between the y's squared and took the square root of both sides. And that works out quite nicely. So distance is distance. It doesn't matter if you have points that are actual numbers or points that are variables. If we wanted to find the distance between the points a plus b, and 5a, b minus 2a, it doesn't matter if it's numbers or variables. If the process is still the same. We still use this formula. This is going to be x1, y1. This is going to be x2, y2. You just have to be careful of following the rules for polynomials when you do this. So the difference between the x's would be 5a minus a squared plus the difference between the y's. Now I'm going to use my parentheses here. B minus 2a minus a plus b. Close your parenthesis, quantity squared. Now I use the parentheses there because of the minus. I'll explain why in just a minute. Now, 5a minus a is really easy. That's just 4a quantity squared. Now, remember, you have to carry this minus through the parentheses when you do this. B, minus 2a minus a minus b quantity squared. So when you combine your terms here, you actually end up with 4a quantity squared plus, well, the b's are going to cancel out, and then you have negative 2a minus a, which is negative 3a quantity squared. So remember, when you square something, you square everything in parentheses. So D is going to equal the square root of 16a squared plus negative times a negative is a positive 9a squared. So D, you can add those together, is going to equal 25a squared. Well, 25 is a perfect square, and so is a squared. So the square root of 25 is 5, and the square root of a squared is a, so the length of D is equal to 5a. So it didn't matter if you had numbers or variables, you can still find the distance in terms of your values. Now, let's try this one. Find the length of JK with endpoints J4263 and K42 negative 37. Do we have to use the distance formula on this? Actually, no. If you notice here, this has these 2 points, J and K, have the same x coordinate. What does that tell you about the line, or the segment that's created? If the x values are the same, this is a vertical line. If the x values are the same, it's a vertical line. So all we have to do is find the distance of JK is equal to the difference between the y values. So we know x's are the same, so the y values are going to be the absolute value of 63 minus negative 37, which is equal to the absolute value of 100, which is equal to 100. So the length of JK is 100. All right, so let's see if we can set up this last one before we move on to the end of the lesson. Well, find the length of PQ with endpoints P 18, negative 29, and Q 46, 67. Would you use the distance formula on this? Yes, you would. So see if you can use the distance formula on this one, and we'll look over the answer on the next class, and then we'll do this last one together before we move on to the homework.